Hi, I'm Steve, and on this channel, I tell you about interesting things related to our world and beyond. Today, we'll find out, what if everyone pointed a laser at the moon? Let's go! Imagine this. It's a clear, silent night. Billions of people stand under the dark sky, holding small, bright red laser pointers in their hands. From every city, every village, every corner of the world, one single command spreads like wildfire. Aim at the moon. For the first time in human history, the entire planet unites to do one thing: point a beam of light at our closest cosmic neighbor. At first, it doesn't look like much. One laser beam is barely visible against the vastness of space. Even 1,000 beams combined don't seem to make a difference. But then, something extraordinary begins to happen. As the number climbs into the millions, then billions, the night sky starts to glow with faint red lines, stretching upward like a colossal web of light. From orbit, the Earth looks as if it's covered in a red halo, a glowing network of energy converging on a single point, the pale, distant surface of the moon.
But here's the surprising part. Even if every single person on Earth used their brightest laser pointer, the moon would barely notice. A typical laser pointer produces only a few milliwatts of power. By the time that narrow beam travels nearly 384,000 kilometers to the moon, it spreads out into a wide, weak circle of light. Each individual beam becomes so faint that it's effectively invisible. But what if everyone participated? What if 8 billion people aimed at the exact same spot at the exact same time? The combined power would reach tens of megawatts, enough to make a small but measurable difference. To the naked eye from Earth, the moon might still look the same, but if you were standing on the lunar surface in your spacesuit, you'd see a faint, shimmering red glow growing stronger every second. It would look like a distant star that suddenly focused its gaze on the moon.
As the beams converge, a curious thing happens. Dust on the lunar surface begins to heat ever so slightly. The temperature rises by tiny fractions of a degree, not enough to melt anything, but enough for sensitive instruments to detect. Telescopes on Earth register the bright spot on the moon growing a little more intense, as if someone lit a small ember on the ancient gray surface. Humanity has just turned the moon into the target of the largest light show in history. But the real magic isn't just the light, it's the coordination. To actually hit the same spot, everyone must aim with incredible precision. Even the smallest misalignment would cause billions of beams to scatter uselessly across the lunar surface. The Earth's rotation, the moon's orbit, the atmosphere bending the light, all of it would make this task almost impossible. Scientists would have to synchronize every beam down to fractions of a degree, calculating angles and positions with the accuracy of space missions.
And then there's the atmosphere. As the lasers travel upward, they scatter and refract in the air, causing a beautiful but chaotic display of glowing beams. To someone standing on the ground, the sky would look alive, like a shimmering red aurora created not by nature, but by humanity itself. Planes would avoid the skies, observatories would go dark, and satellites might catch surreal footage of the Earth glowing from space. Now imagine the view from the moon. There is no air there to scatter the light. If you stood in the Sea of Tranquility and looked back at Earth, you'd see an entire planet staring right at you. Billions of faint red beams merge into a single shimmering point. It wouldn't be enough to blind or burn, but it would be one of the most breathtaking spectacles in human history. A signal not just of our technological reach, but of our shared existence. One planet, one moon, one moment. But what would happen if we used something stronger than tiny handheld lasers? Suppose nations decided to participate with powerful industrial or military-grade lasers. The total energy hitting the moon would skyrocket. At gigawatt levels, the lunar regolith could start to heat significantly, possibly vaporizing small patches of dust. From Earth, the bright spot could become visible even to the naked eye. It it would look like a star shining back at us from the moon's surface, a silent mirror reflecting our ambition. Of course, this idea also reveals something about the scale of space. Even united, humanity's collective power barely scratches the surface of the vast distance between us and the moon. The experiment would be less about changing the moon and more about realizing just how small and fragile we are in the cosmic scale. Billions of beams working together still only create a faint glow on that cold, silent world. Yet, it would be unforgettable. Children would look up and see the red-tinted night sky, wondering how billions of people managed to do something together. Scientists would measure, engineers would calculate, artists would marvel. It wouldn't be an act of war or conquest, but a global performance. Humanity pointing to the moon and whispering, "We are here." Long after the lasers switch off, the moon would remain the same, cold, silent, unchanged. But down here on Earth, something might be different. For one brief night, 8 billion people aimed their light at the stars, united not by borders or language, but by curiosity and wonder. And maybe, just maybe, that would be brighter than any beam of light we could ever send.